We just finished discussing in the previous video about the different numbers of solutions that can exist in a system of equations. Remember, we talked about there can be one solution if we have two lines that cross at one point. Parallel lines that never cross would have no solution, and lines that are on top of each other that would have the same slope would be an infinite number of solutions. So is it possible to maybe determine the number of solutions that a system of equations has just by looking at their equations? Well, it can be. So if you look in the side margin of your textbook, you can see the different ways that we can tell by just looking at the slopes and the intercepts of the equation. So the key one here is if we have different slopes, then we know for sure that the lines are going to cross, therefore they have one solution. So that would be the easiest one. Now, if they have the same slope but different y-intercepts, then there is no solution, okay? Because if they have the same slope but they cross the y-axis at a different place, that means they're parallel lines and they never cross. Now, the other option then would be to have the same slope and the same y-intercept, and then that would be infinite solutions. So let's take a look at example 6 on page 237. All right, so remember what we're looking for. Different slopes means one solution. Same slope could mean either infinite solutions or no solutions depending on the y-intercept. So let's take a look at these equations. Well, the problem is we don't even have an equation. What they've given us is 2 points. But due to previous lessons, you are now experts at coming up with equations from 2 points. Okay? So that was my first set of points. The other ones are the points 1, 1, and 0, negative 1. So how do I find an equation of the line from 2 points? Well, the easiest way to do that is to turn it into a table. So if I take 2 and 3 and 0 and 5 and place them into a table, I can try to find the change in y and the change in x. So the change in y would be from 3 up to 5, which is a change of positive 2. The change in x would be from 2 down to 0, which is a change of negative 2. Okay, so we have negative 2 over 2, okay, which is going to give us a slope of negative 1. Now, what about this other one? Well, let's do the same thing. Let me make a table. All right, so I put 1, 1 there, and I put 0, negative 1 here. Same thing, we're looking for a change in y over a change in x. The change in y, we go from 1 down to negative 1, which is a change of negative 2. And then for the x's, we go from 1 to 0, which is a change in negative 1. So negative 2 divided by negative 1 is in fact 2. So in this situation, our slope equals 2. So now we can examine the two different slopes. Here I have a slope of 2. Here I have a slope of negative 1. And remember what we said before. If the slopes are different from each other, that means when we graph the lines, they will cross. And if they cross, they will have one solution. And just to verify that, we have a graph of these two lines, and as you can see. Here we can see them crossing at the point 2, 3. So we have two lines, different slopes, they cross, and that is how we're able to come up with a solution. So just remember, if we're able to graph the lines, that's great. We can see where they cross. But sometimes just by examining the slopes, right, the slope of one line, comparing it to the slope of another line, we're able to determine if what the solution of the system of equations would be, or how many solutions that would have. Okay, so we've done a good job so far. We've got one more got it problem that I'd like you to try at the top of page 238.